I hope you'll bear with me. I'm sort of backing up a little bit here, just one one small step for a man. Uh, just because see, in the past, I usually teach the basic implementation of file upload, and then when we discover the issue that is going to be there, glaring issue, then we look at how to fix it. But I think that this time around, especially with the online nature of how delivery at the moment, I'm just going to give it all up to you with the better solution right up front. I think it might be less confusing. I hope so in the long run, anyway. Okay, so I just add a little note here. Thing is, blobs, by definition, binary large object, right? They're large, okay? So we're going to see that using a one-to-one relationship makes it much easier for us to manage these files or other binary large objects that we've uploaded, because sometimes we don't need the full object, right? We aren't actually accessing the PDF file or whatever. We just need to maybe list what the file names are, for example, and things like that. So rather than move around that huge amount of data all the time, there's a better way, right? And that's what we're going to share with you. Usually I let you discover this problem and then we go back and fix it. But let's just do it right the first time, I think, this time. Okay, so looking back at that last slide we were looking at, if we take this approach, so right in the patient class, right, I add this content, MIME type file name, these properties directly there, then every time you select a patient, right, you're going to get, okay, if you've uploaded a picture for the patient, a profile picture, things like that, then you're going to get all that data, a huge amount of data, like probably 10, 20, 50 times the amount of data that you would need to transport back and forth across the network than if you just had the basic textual information for the patient, right? What it comes down to, let me back up one slide. Um, oh, silly animations. There we go. All right. So when we think about these three properties that we talked about already that it takes, it's really the byte array. That's where the bulk of all the content of the blob, the binary large object, goes into that byte array. So they can be huge, right? If all we need is the file name and maybe, although we'll never change the MIME type, we might want to make it keep it close by and handy in case we want to filter, right? If we have a whole big collection of files, maybe we only want to see one type of file, right? So having the MIME type close by and handy is a good thing for that. But leaving the content, the huge byte array that holds the actual file itself, the bulk of the blob, right? Leaving that out so we can dot include it, right, whenever we need it, but leave it out if we don't. That makes our system much, much more efficient. So at the same time that we're going to learn about working with blobs, we're going to introduce obviously a one-to-many relationship, sorry, a one-to-one. Bite my tongue, okay? Because what we can do is we can offload this one property out of the class and only include it when we need it. How's that going to work? Well, let me show you. Okay, let me just get rid of that one. So I've added here the PowerPoint on relationships. Yes, that one we've gone through many times. It was a key for people to understand what they had to do on the test and so on and so forth, right? So now let me just get it started here again. Right, you remember this one. All of our POCO are plain old CLR object relationships. Okay. Now I'm not going to review the earlier ones, the one-to-one, the two different varieties of that, the different varieties of many-to-many. Let's talk about one-to-one. Okay, not as common, but it's very useful for the real world and modeling what the real world looks like, right? It also can be used, as in our case, to offload rarely accessed properties out of the main or principal entity, right, into a dependent entity. And then we can always include it if we need all those rarely accessed ones. I can even think of an example like, you have an employee record at a company, right? Their name, address, all their contact information, so on. Well, what about things like their passport information? You might have to have that, but you don't, every time you go and pull up an employee record, you don't need all their passport data, right? But, there's only going to be one passport for the employee, so why not offload that in a one-to-one in a separate entity that you can include only when you need it? So that's going to be the general approach, but we're going to take advantage of the fact that we can offload the massive bulk of our blob objects, right? So most one-to-ones are technically 1 to 0 or 1, right? You don't have to have this dependent entity, right? If you do, you can force the system to automatically always have it there as well. But, for brevity, I'm just going to talk about one to one, even though normally I'll mean a 1 to 0 or 1, right? We don't have to have that related child if you prefer to call it that. Okay. Um, and there's more than one way to model a one-to-one with Entity Framework Core. We'll look at both of them because it's good. It's useful to sometimes have both of these in your tool belt because there are times when it's absolutely necessary to use one style versus the other style. Okay, so first of all, right, author and biography. Okay, yeah, so you might have all kinds of information about the author, their name, anything else is relevant. Perhaps they have some sort of a authors guild registration number, things like that might all be in the author table, right? For their biography, though, all the details of what they've done in the past, well, you don't need that. Every time you want to pull up a list of authors, maybe for a quick contact list, you don't need the whole biography, right? So we can put all of those fields in a separate entity, okay, and only include them with the author when required. And all it really takes is this approach. Look familiar? Essentially, each of the entities has its own integer identity primary key, right? I included it here just for clarity. But in the dependent entity, the biography, notice we have the normal properties we would have for a one-to-many. The integer, author ID, foreign key, and a public author, right? A single one of the parent or um, principal class, right? The principal type, okay? And in the author, the difference we see here from our one-to-many is that instead of having a I collection of biography objects, we have a single one, public biography, right? And that's enough. That will tell the system, it will look at that and say, hey, this is not a one-to-many, this is a one-to-one. How will it enforce that? Well, in the biography entity, it will automatically add a unique constraint, a secondary index set as unique on the foreign key on author ID. That way you can never have more than one biography for an author, hence it becomes a 1 to 0 or 1, right? You don't have to have a biography for the author, okay? But you can add one and then access it, include it with the author whenever you pull up the author information if you need all the biographies and so on with the authors. Okay, so that's one of the two ways of actually implementing it. Another alternate approach, now maybe just before I go to the next slide, I'll point out, notice that each has its own integer identity primary key, both entities, right? But because we're putting a unique constraint in the biography entity on author ID, you might argue, well, why do I have two different integers that are both guaranteed to be unique? Why not just have one? So we can do that with a bit of work with an annotation, right? So an alternate design would be like this. Okay, we just have a public int. Usually we would go with the class name ID, right? And we have to annotate it. So we annotate it that it is both the primary key, the key, and a foreign key. And specifically, we'll say foreign key for what entity? For the author entity. And that's it. Okay, so the author doesn't change. The same single copy of the dependent entity is in there as a property. But the child no longer has a separate integer identity primary key. It has just the foreign key that is doing dual purpose because it is guaranteed to be unique anyway. Uh, and it functions as the foreign key for our author, right? So in other words, in the biography entity or table, the biography ID will be match the value of the corresponding author's ID, right? So that's just two different ways to create a one-to-one relationship with Entity Framework Core. All right. Just, before we leave this topic altogether, just think about some of the other uses of one-to-one. Okay. This is an example from an old textbook we used to use before it got too out of date. But basically, think about on a farm. Maybe the farmer needs a database of all their animals, and there's certain common properties. So every animal on the farm probably has a date of birth or a date that they were acquired, things like that. There might be other things, weight and so on and so forth, right? Weight, height, whatever, that are common to all animals of every type. But there are certain properties that, for example, only a horse would have, like, I don't know, furlong speed, things like that. And sheep, wool quality, wool density, things like that, that you might have tracking in a sheep entity. Well, to have all that in a single entity under animal, many of those properties will be null because they aren't applicable, okay, to every type of animal. They're unique to only one subtype, right? So a situation where we have subtypes like this, we can often utilize a one-to-one, right? Or 1-to-0 or 1. So an animal might be a horse, in which case, you would actually then populate the horse property inside the animal with all the details of the horse or sheep or whatever, right? So it's just another use of a one-to-one. Okay, that's enough for now. We're going to come back and look at how we can use that for pictures as well in a little while. But let's carry on with our first demo, right? Our demo of file upload that is in our attached file here. So I'm going to use this file as I go through. What I've downloaded is the latest version of our medical office, like is 9.5, right? So we're going to use that as a starting point and we'll work from there. It's kind of a lesson plan in the instructions here as well. So I have my own copy open on the other screen that'll make it easy for me. Okay, so the scenario basically is, right, we want to manage documents related to a doctor. Now, I chose doctor just because we already have so much stuff in the patient right now, right? The controller is getting quite busy with other codes. So because the doctor is relatively simple at the moment, I thought it'd be easier to kind of see our code for our first look at incorporating this technique into a controller. I just thought I'd use the one that was a little less cluttered at the moment. So documents related to a doctor could be various copies of certifications they have, diplomas even, letters of accommodation, who knows what, right? Okay, so what we're going to find is we can actually reuse these classes for numerous things, but in the models class, I'm going to start off by making one just to hold that bulky content of our blob, our binary large object. So I'm going to call it file content, right? And it's going to relate to our actual uploaded file. So that's going to be the name of my next class. So I might as well add that now, right? It'll be uploaded file. I was tempted to just use the name file, but that's kind of a key name. So good to avoid key names, right? And so I went with uploaded file because after all, it's a web app. It must have got here by uploading it, right? Okay, so coming back to our file content. Basically, I end up with this approach with three properties in here. The main one here is my content. That's that byte array, right? So I have to add some usings. Of course, our data annotations. That takes care of key. Now the foreign key, that actually is in data annotations.schema. Okay, so now we have the usings we need up here, right? So let me get back to this. So the byte array holds the actual bulky content of our binary large object, our file that we've uploaded, right? To maintain the relationship back to uploaded file, right? We have a public uploaded file object in here. And here's our dual purpose primary and foreign key, file content ID, right? So we use the annotations to note that it's the primary key. Now, mind you, it's smart enough to know that it will not generate this as a integer identity. It won't be automatically generated values because it has to correspond back to the automatically generated one in the updated file class, right? So it's the foreign key. It will inherit, so to speak, its value, right, from the actual principal class. Okay, so let's get our properties inside here. So for our uploaded file, right, we have our integer identity ID, okay, like normal. We have a file name and a MIME type, just as we talked about. I'm not going to worry too much about the MIME type other than setting a size. As I said, we don't normally ever edit the MIME types, but it's nice to include it here so that, if I want to just pull up information from the uploaded files, right, then I can know the file names and possibly filter for different MIME types and so on. And I never actually have to, if I don't want to include the file content, right? So the bulk of the file can be left behind in the database. I don't need to bring that across the network just to see what the file names are and so on. And anything else, possibly down the road you might decide that the file name isn't enough, that we want to actually be able to write descriptions and so on of these different files, these different binary large objects, right? So you could add additional properties in here as well. But the point is to leave that bulky file content out unless we absolutely need it, right? So we do in the constructor here, just make sure that we have the file content ready in case we need to access it. By the way, by doing this, okay, it guarantees that when we create an uploaded file, it creates an actual file content object. So technically we're looking at a one-to-one, a true one-to-one, rather than a 1-to-0 or 1. But that's a side point. All right, so we have our two classes here, and that will look after any kind of files we want to store. Actually, and we can use these across the whole system. Now to kind of prove that point, let me just add another class here. So this is our first chance to really see our entity framework as an object relational mapping system. So far, all of our entities have been in a one-to-one. You make an entity, a class, a model class, and then it corresponds to a table in the database. Well, we're going to get away from that in this example, right? So what I'm going to do here is I'm going to make an entity to hold each document related to a doctor. Now it's going to inherit from my uploaded file, right? So it gets all of those properties and so on, including its own dependent file content, right? Will be available through it as well. So how does this document relate back to the actual doctor? Well, it's a one-to-many, right? We can have many documents for the doctor. So in a typical one-to-many, we have our foreign keys, right? So I'll just add the data annotations namespace. So we have our public int doctor ID and our doctor, right? And that's it. Notice we don't add a separate primary key because actually it inherits the primary key for this doctor document object from uploaded file. Because remember that had its own integer identity right here, right? So it will just work this way. Now, just to show you, well, I'm not going to even use it, but I'm going to include this. I don't normally put multiple classes in one class file, but just for demonstration purposes, I'm just going to throw in as well. Suppose we wanted to have documents related to patients, right? We're not actually going to implement this, but I just want to show you we can reuse our uploaded file to track any kind of documents in a relationship to any of our entities, right? So this would again be a one-to-many. A patient might have many documents. I'm just throwing that in so we'll have a chance to examine and look at the actual tables created in the database and see how this all plays out. Okay. All right, so that gives me the basic classes that I need. Now, of course, I'm going to have to do some work inside of Doctor to implement that, right? So inside Doctor, I'll come down here. We'll throw in our Doctor documents. And I should probably as well, just because it's a collection, right? I'll come up here and in the constructor for the doctor, we'll prepare an empty hash set. Now this does not force the creation of any doctor documents, right? It just means that the property inside our doctor object isn't null. Okay. And then we'll come to our DB set, our DB context, and we'll add our doctor documents here. Notice we don't have to create a DB set for files unless we want to, right? But we could. We could create a separate DB set for uploaded files. Actually, I think I will. I could finish the demo without this, but later on it will be useful. DB set of uploaded file. Oh, let's have a capital. Okay, so let's just do a migration then. So I'll need to just save everything. Come up here, because I'm using SQLite, I'll blow away the database and the migrations folder. All right, and now we'll just Put my common commands, and we'll run this command to re-add our migration. Should do a build, but this will force one anyway, so hopefully I won't get a build error. If I did, it's not a big deal. I just ask for build again, then I'll see the details. So all the usual warnings about the schema, right? But that's okay. Now let's just come down here and have a look at what we've created inside the migration itself. So these are the tables, haven't changed much here, right? Now will we find a doctor document table? No. Okay. We have uploaded files as a table, right? And look at this. It has a doctor ID, okay? Has a discriminator column, right? You know what? I didn't create the notice it's a nullable foreign key. So not every uploaded file will relate back to doctor, right? Actually, let me do that again. I'm going to delete this. I haven't created the database. Just so you can see the full process. Let me come to patient, the patient model. And I'm going to do the same thing. I'm going to add the I collection of patient documents. We created the patient document class, but I didn't relate it back here because I didn't finish the process, right? No, it's patient. So I'll make a collection of patient document objects for patient documents, right? And up here, we'll add it to the constructor. Patient document. Okay, now I'll do a build just to make sure. All right, good. So let's come back to the package manager console. Kind of a shame I closed it, but there we go. All right, we'll just repeat the same command. Okay. Now, let's have a look at the difference, right? If I come down, find the uploaded file table. Sorry, you're probably getting busy looking at the screen, but I have to. Okay, uploaded files. Here we go. Look at that. Now there's both a doctor ID and a patient ID, but they're nullable foreign keys. And it's added a discriminator column, right? It's a string. So what you'll see in the data is this will actually have the name of the appropriate parent, doctor or patient, right? Will be stored inside discriminator. And that's how it actually internally will know that, okay, this uploaded file belongs to a patient versus a doctor, right? These are typical. The file name, the MIME type are just strings, okay? Notice the keys here, right? It has its own primary key, the ID, which of course you know up here is set to auto increment, right? And then we have the two foreign keys, doctor ID and patient ID, okay? And they're both set to cascade delete. That's something I didn't talk about earlier, but it's obvious that you would want cascade delete, the default arrangement anyway. So you don't need to do anything in the Fluent API to enforce that. It's the default, even with a one-to-one like this, because it doesn't make any sense. Why would you leave doctor documents behind if you were going to delete the doctor, for example, right? So cascade delete is what we want anyway. Okay, and then of course here's our file content. Oh, wait a second, I didn't even make a DB set for that. But of course the system sees that it's a dependent entity in relation to uploaded files. So here's file content, right? It just has the file content ID, right? Nullable is false. You'll see that it is the primary key, but it is also the foreign key, right? Relating back to uploaded files, okay, with cascade delete. Obviously, if we delete uploaded file, we would want the content, that byte array, to be deleted as well. And that's all we add, right? So it's a multi-purpose, okay, file. This uploaded file, so we can have patient documents, doctor documents. We can have other entities in our system, and it's all stored in the one table. So it's a chance to get away from having a one-to-one correspondence between an entity and an actual table in the database. Okay, so that's good. So it will actually generate the database for us next time we run and our seed data. I'm not going to worry about trying to seed any documents or anything. We'll do that as we go. All right, so let's gosh, we got 25 minutes. So I'm going to stop and start again.